Palash, Badjatya in civil engineering and engineering mechanics, presenting fresh cement paste behaves like the human body, and that can help us 3D print buildings.
If concrete were a country, it would be the third largest producer of CO2. Now, reducing that would be beneficial, won't it? But we have a housing crisis that requires us to build more and more. 3D printing is a stone that can help us kill both these birds. In 3D printing, we rely on the concrete to hold its shape, to print layer by layer with minimal material usage. And we can also print in hours and not days because we're not using any molds. So how does concrete hold its shape? The main ingredient, cement, it reacts with water, and the two coexist with the reaction products to create a viscoelastic fluid, which is basically both a liquid and a solid, like peanut butter. While the liquid part helps us print, it's the solid part that helps with the shape stability that we're looking for. In my research, I use whatever we know about cement chemistry to figure out what is responsible for the solid behavior, what are its limits, and how do they change with time. I use a technique called oscillatory rheology, where I stretch the material and let it go, and I stretch it more and more in each cycle. So at first, cement behaves like a solid, and it goes back to its original shape when I let it go. But as I keep stretching it, there comes a point, a limit, beyond which the structure breaks down. I saw that this limit was increasing with time, and this hadn't been seen before. So I mixed cement and water in different proportions, changing the reaction behavior, and this helped me show that the solid strength and its stretchability is actually coming from two different sources. Cement particles stick to one another through electrostatic forces, but they only create like a flimsy house of cards structure. But as the cement polymerizes, the chains connect everything together, allowing the material to stretch without losing its capacity. So compare this to a human body, where the cement particles are the skeleton and the muscles are produced by this polymerized cement. So understanding how these muscle works can help us control them and make them more suitable for 3D printing. Now, I hope this leads to more mass housing that is both affordable and sustainable and unencumbered by molds, and regardless of wealth, people can live not in blocky houses, but in beautiful homes that are expressions of themselves. And that, I believe, is not a stretch.